In this section, we'll be talking about ratios. Ratios are very similar to fractions. Fractions speak in terms of parts of a whole, and ratios are used to be able to compare items, or relationships. So the first problem that we have here, it asks, write the ratio as a fraction in lowest terms. So ratios and fractions look the same. You're also going to be setting it up in terms of a part over a whole. So just as we do with fractions, I'm going to take the first value that I'm given, which is the 14 hamburgers, and I'm comparing it to 20 hot dogs. So the ratio as a fraction is 14 over 20. And then, like any fraction that we've dealt with previously, to get it into lowest terms, we need to identify common factors. Well, both of these are even numbers, so I'm going to just divide both by 2, and that gives me 7/10. Now, because it's an application and we are comparing two things, we need to include those units. So it's 7 hamburgers, and 10 hot dogs. Okay, so let's move to the next one. We have 16 ounces of chlorine to 50 gallons of water. So same thing, part over a whole, or one unit over another. In this case, we have 16 ounces per 50 gallons. Now, and I like to include units. I didn't in the first one because I also hesitate with units because it can cause some confusion. But when you're dealing with something that has to have units at the end, I always feel like it's a good idea to set the problem up with the units. As I'm working with it, I drop the units and then put them back in. So a couple different ways, but again, the key is that you end up with units at the end. Okay, so I'm this time just rewriting it without units. These are both even, so again, I can factor out a 2 from both, and I get 8 over 25. So 8 ounces to 25 gallons. So when might we encounter something like this? Well, think in terms of a pool, for example, and you put chlorine in a pool to sterilize things so that people don't get sick. So something like this, a ratio that says 8 ounces per 25 gallons, that could be, okay, for that pool to have the amount of chlorine that we need, for every 25 gallons that we put into that pool, we need to add 8 ounces of chlorine. So that's a real life scenario where you could benefit from a ratio. All right, so for number 2, we are doing the same thing, but we need to pay attention to the units, and in some cases, we may need to do some conversions between units. So for 2A, it says compare 18 minutes to 2 hours in minutes. All right, so that comparison is a hint that we are setting up this ratio, okay? So we have 18 minutes over 2 hours. Now, here we're comparing 18 minutes to ultimately minutes. So we don't have the correct units for everything. We're starting with minutes and hours, but we need to end with minutes and minutes. So we need to change the hours to minutes. So the question with that is, how many minutes are in an hour? Well, there are, I'll write it over here, 60 minutes per 1 hour. So if we have 2 hours, how many minutes do we have? Well, we have 60 plus 60, right? Or 2 times 60, and that equals 120 minutes. So we need to rewrite this fraction with an unchanged numerator and an updated denominator so that we have minutes that we are comparing. So that has everything that we need. The conversion is done, the unit is correct, but we still need to write this in lowest terms. So let's see here. 6 actually goes into both of these. So I'm going to divide by 6, divide by 6, and I get 3 minutes over, let's see, divide by, okay, so 20. And that is your final answer. So the difference between these problems for number 2 and the problems in number 1 is that we need to do a conversion because our units aren't the same. And you need to end up with the unit that you're being asked for in terms of the answer. All right, so let's go to 2B. And we have compare 10 minutes to 1200 seconds in minutes. So same thing. We have 10 minutes. We're comparing it to 1200 seconds, but we need the answer to be in minutes. So that means I need to convert the seconds to minutes. All right, so just like I did previously, I'm going to write the ratio with what I'm given. So at least I can visualize where I'm starting. Okay, and then over here, I'm going to do my conversion. So 1200 seconds, and I need to convert that to minutes. Now, we've talked previously about how to identify whether you're doing multiplication or division. When you're going from something small, like in 2A, right? We started with 2 hours. Well, there are more minutes than hours. So our number is going to be getting bigger. The quantity isn't, but the number is, right? Or the amount isn't changing, but the number is, because there are multiple minutes in an hour. We used multiplication. For this one, we're starting with 1200 seconds. Well, there are fewer minutes than seconds, right? Because in 1 minute, there are 60 seconds. Okay, so that means we have to use division. So we can use the same concept that we have before when we're talking about multiplication versus division. So the question is, how many seconds in a minute, which I did already mention, but we have 60 seconds per 1 minute. So to convert to minutes, I need to take the 1200 and divide it by 60. And that is going to give me how many minutes I have, which again is what I need in order to be able to rewrite this fraction in the way that they're looking, or this ratio in the way that they're looking. All right, so this becomes the 10 minutes, which is unchanged, over 20 minutes. Now I need to write it in lowest terms. Well, I see that 10 goes into both of these. So I'm going to do divide by 10, divide by 10, and that gives me 1 minute over 2 minutes. And that is your answer. All right, so now we're going to use ratios, those comparisons, to find values, okay, to continue looking at relationships between things. So for here, it says the price of apples went from $2.25 per pound to $3.55 per pound. Find the ratio of the increase in price from the original price. So there is a formula, a way of setting this type of problem up every time you see one. And what you're doing is you care about the difference between your original price and your new price. you're comparing the difference to the original price. Okay, increase, and you can see it mathematically, but increase is saying that your new price is higher than your original price. If it said decrease, right, then your new price is lower than your original. So the way that we set this up always is we take the new price or new value minus the old price or old value. That gives you the change, right? The difference between them. And that is what you are comparing to the original price. So I'll say old price, old or original. Okay, so now we just need to figure out, well, which is which of the information that they've given us, right? What goes where? So the price of apples went from $2.25 per pound. So this is the original price, right? Or I'll say old, since that's what I used in my little formula thing here. Okay, and then the $3.55 is the new price. Now we also have a second usage for the original price because that's what we're comparing this change to. So we need to make sure to include, and again, I'm just going to change the terminology here because of how I labeled what we're using on the left. Okay, so now it's just a matter of putting the information in. So the new price is $3.55 minus the old price or original price, which is $2.25. And then I have to put that over the thing that we're comparing it to, right? Which is the original price or old price. So that's going to be $2.25 also. Now I can just start simplifying. So I need to subtract the top, which is $3.55 minus $2.25. Now, if you ran that in your calculator, like I ran it in mine, and I got 1.31 3/10. But again, remember, money always needs to be rounded to the hundredths, so I need to include that zero there. And then I have 2.25. Now, typically we can't have decimals in our final answers when we're dealing with ratios and fractions. However, it doesn't actually state here that you need to write this answer as a fully reduced fraction with integers or ratio with integers. That's something that we will learn actually in the next part of this video. So for the moment, I'm going to leave that answer, and then you'll learn how to change it so that you don't have those decimals. Okay, so for this next one, we have the weight of luggage a person can carry on the plane went from 51 pounds to 72 pounds. Find the ratio of the increase in weight to the original weight. This problem is the same type as the previous one. We're starting at a weight, we're moving to another weight, and we are finding the ratio between that change and the original. So that means that the setup is going to be the same. So we have the new weight minus the old or original over the old or original. Now we just need to figure out what values go with which part. So in this case, we started at 51, so that's the old weight. Then we went to 72, that's the new weight. So just looking at those values, notice that they go up. So when it asks for the ratio, it says find the ratio of the increase in weight. Well, that increase we can already see by looking at the first weight versus the second. So this could be written as find the ratio of the change in weight to the original weight. because by doing the difference the way that we are, right, the new value minus the old, that's going to take into account the direction of the change already. So I just want to make you aware that this problem could be written including the word increase, decrease, or not, and just looking for that ratio. So be careful of that. Okay, so I have identified my values. So I have 72, that's my new weight, minus my old weight over my old weight. Now, I run that calculation, so I do my 72 minus 51, and I get 21 over 51. So the ratio of change to the original weight is 21/51.